Hello, this is Unit 7, Lesson 3. We're looking at solving exponential equations. All right, remember an exponential equation or function has a variable in the exponent. All right, the first thing we're looking at is just making sure that each side of the equation we have common bases. All right, so again, the base is what's being raised to the x power. Okay, so let's look at some examples. You can try some as we go. All right, so this first one on the left here, 3 to the 2x equals 3 to the x plus 1. All right, so think through this, right? It's an equation. The left side's equal to the right side. Okay, the bases are equal. So in order for this statement to be true, the exponents must be equal. Okay, again, this only works for an equation. You can't just cancel out the bases if you're simplifying or graphing or whatever. All right, we're solving an equation here. For this equation to be true, that means 2x has to equal x plus 1. Okay, subtract x from both sides, we get x equals 1. Not bad at all. All right, go ahead and try number 1 to the right. All right, so again, pretty straightforward. The bases are already the same. Must mean the exponents are equal to each other. Set them equal to each other, solve for x. All right, let's look at the next type. So to the left here, 9 to the x equals 27. All right, so these are not the same bases. This is where you've got to know some of your perfect squares and cubes and fourth powers, etc. Okay, so try to get each side to the lowest base possible. Okay, you could say, well, I want both bases to be 9. Well, there's not really a way to get 27 to get that base to be 9 without some kind of fractional exponent. You should all be able to be reduced to whole numbered exponents. Okay, so with the smallest base possible. All right, so 9 is just 3 squared, so I can substitute 3 squared for 9. So it's 3 squared now to the x power. All right, so can I reduce 27 to a base 3? We can. 27 is just 3 to the x, or excuse me, not 3 to the x. 3 to the third. All right, so we can simplify the part on the left. All right, so raise a power to a power, and multiply 2 times x. So we have 3 to the 2x equals 3 to the third. Now we have common bases. So that means 2x must equal 3. X equals 3 halves. Okay. Go ahead and try number 2 to the right. All right, so some of you are probably thinking, Mr. Hilliard, why are you giving us the harder one than the example? Well, I'm sorry about that. But we should be able to do it. You just got to be careful. The rules still apply. This is still an exponent. Do that in a different color. This is still an exponent raised to a power, so we're still multiplying. You just got to make sure you distribute. All right, so you get 2 to the 2x minus 6 equals 2 to the 3x plus 9. Okay, so you solve for x and you say, wait a minute, can I have a negative exponent? Well, sure. What does a negative exponent do? It just flips the base. Okay, it doesn't make it negative. This is not extraneous. This is okay for now. That'll be different when we start solving log functions or log equations. Okay? All right, so moving on. 1/2 to the x minus 10 equals 1. Okay, so there's a couple different things going on here. 1/2, how do we get that to a common base? How do we get that and 1 to a common base. So let's look at the right side. Well, you got to remember, any number to the 0 power equals 1. Okay? So whatever the 1 on the left is, we can make the base on the right that the same very easily by just raising it to the 0 power. So on the right, we're going to have some number to the 0 power. All right, so 1/2. Well, 1/2 could just be 2 to the negative 1. Remember, negative exponents just flip the base. So this is 2 to the negative 1 to the x minus 10 power. So that means on the right, I can do 2 to the 0. And that is the same as 1. So now I have everything in base 2. All right, go ahead and multiply your exponents. So you get 2 to the negative x plus 10. Don't forget to distribute to both terms. Equals 2 to the 0. And you're thinking, well, how do I set these equal to each other? Well, something can equal 0. It's no big deal. Negative x plus 10 equals 0. Subtract 10 from both sides, or add x to both sides. Let's just add x. That might be easier to look at. All right, so I get 10 equals x, or x equals 10. Okay? So try the number 3 to the right, and check your answers when you come back. All right, so your common base here is 2. Just remember your negative exponents. Whenever you have a fraction, your negative exponents will flip the base. Okay? That's how you get to your common base. Just use your negative exponent. All right, so the last, on the back of the paper here, we're using e. Oh my goodness, it's e. I don't know how to do this. Well, e is just another base. It's just another number. In reality, when you're solving exponential equations this way, the base doesn't really matter. Once they're all on the same base, it's actually easier for you to work with. So the fact that they're all e, they're all base e, makes this a lot easier of a problem, because we don't have to mess around with certain powers or anything. But we are dividing, so that means we subtract exponents. All right, so on the left side, we would just write e to the x plus 3 minus 2x minus 7 equals e to the 2x plus 1. All right, simplify. E to the x plus 3 minus 2x plus 7 equals 2x plus 1. So let's simplify this left side. We'll get negative x plus 10 equals 2x plus 1. Let's add x to both sides, subtract 1 from both sides. We get 9 equals 3x, or x equals 3. All right, so don't panic when you see e. It's just another base, another number that we can use. Treat it like any other base. Be thankful you don't have to try to find a common base with that. Okay? All right, so go ahead and try number 4. All right, so we did a couple different things here. Wanted to see if you could remember to use a 0 power to find a common base. All right, make sure you subtract those exponents when you're dividing a common base. All right, so you should get x equals 1/2. All right, please make a note of any questions. We'll have the classwork for this next time. See you then.